Now we'd like to look at the general binomial expansion, and this is finishing out State Standard 20. You know the binomial theorem and use it to expand binomial expressions. In the previous adventure, we just looked at expanding binomials without the particular theorem. So this says any binomial a plus b and any whole number n, a plus b to the n power is the same as a to the n plus n, choose 1, or n over 1, times a to the n minus 1 power times b plus n times n minus 1 over 1 times 2 times a to the n minus 2 power times b squared plus n times n minus 1 times n minus 2 over 1 times 2 times 3 times a to the n minus 3 power times b cubed plus etc. all the way out to b to the n. Now don't be overwhelmed, but there are several ways to write this. Here's an alternate notation. N factorial. I know we haven't talked about factorials yet, but a factorial, like 3 factorial, just means 3 times 2 times 1, is a number times all the integers that are less than that. We're going to multiply them all together. So 5 factorial would be 5 times 4 times 3 times 2 times 1. So this would be n factorial over n minus 1 factorial times 1, or n factorial over n minus 2 factorial times 2 factorial. There's another notation for that. Here's another notation. Yes, this is not just one continuous formula. These are 3 ways to write the same formula so far. This says n choose 0, n choose 1, n choose 2, n choose 3, n choose n. And that's a button on our calculator that lets us do what's called combinations. I know we haven't done the combinations yet, but it's fairly simple to use the button. Here's another way of writing that notation, because we see it as n choose 0 times a to the n choose 1 times a to the n minus 1 times b, plus n choose 2 times, and you see this button on your calculator, NCR. You would type the first number in, hit the function NCR, hit the second number, hit the equal sign. That's how we would get these coefficients. Continuing on, times a to the n minus 2 power times b squared, plus n choose 3 times a to the n minus 3 times b to the third, plus n choose n times b to the nth power. So there's the official definition for combinations. N choose R is the same notation as N choose R, just 2 different ways of writing the same concept. This one you see on your calculator. That, if you don't have that button on your calculator, is calculated as n factorial divided by the product of n minus r factorial times r factorial. Factorial, again, is whatever number times all the integers less than that are positive. So 5 factorial would be 5 times 4 times 3 times 2 times 1, which is 120 if you want to check your calculator, by the way. So you want to look for these buttons on your calculator, n factorial, NCR, which is the combinations button. And if you looked at the web, first week of school, I suggested that you have these buttons on your calculator. So it will make your life so much easier. So when we're asked to find the first 4 terms of the binomial expansion, a plus b to the 15th power, we can write it out as 15 choose 0 times a to the 15th plus 15 choose 1 times a to the 14th times b plus 15 choose 2 times a to the 13th times b squared plus 15 choose 3 times a 12th b to the third. And again, the powers of a are descending, a to the 15th, a to the 14th, a to the 13th, a to the 12th. Powers of b are ascending, b to the 0, b to the first, b to the second, b to the third. Notice the degree of every term here is 15. All those exponents add up to 15. So this is just another way to get the coefficients without Pascal's triangle. And it's much faster if we're just looking for a few terms. 15 choose 0, if you do that on your calculator, is 1. 15 choose 1 is 15 on your calculator. 15 choose 2 is 105. 15 choose 3 is 445. Again, the way you would do that is you would type the number 15, do whatever buttons you have to do to get that NCR button on your calculator going, then type the number 3, then hit the equal sign or execute, and you should get 455 for 15 choose 3. All right, let's find the first 5 terms of a minus b to the 12th power. So that should be, for the coefficients, 12 choose 0, a to the 12th, 12 choose 1, a to the 11th, and instead of b, we want to write the opposite of b in parentheses to the first power, plus 12 choose 2, a to the 10th, the opposite of b, which is that expression, to the second power, And then 12 choose 3, a to the 9th, the opposite of b to the 3rd power. And then 12 choose 4, a to the 8th, the opposite of b to the 4th power. All right, 12 choose 0 is 1, so that's a to the 12th. On your calculator, 12 NCR1 is 12. But times a negative makes that negative, and then that's a to the 11th b. 12 choose 2 on your calculator is 66, or 12 NCR2 is 66. Times a to the 10th, and then this negative b squared stays positive. 12 choose 3 is 22, but that's times a negative b, so that's negative 220. And that's a to the 9th, b to the 3rd. And then the next, we're going to have 12 choose 4 is 495, a to the 8th, b to the 4th. Now sometimes you don't want to find all of the terms. Last couple examples, just the few first terms or the last few terms. But there's another formula that is not in your book, and this is kind of a variation of a formula I've seen in a book. I think it's a little bit less confusing to apply it if you memorize it this way. So let's find we're looking for the rth term of a binomial expansion raised to the n power. So for instance, maybe we had this. We're looking for the 5th term of something to the 12th power. R would be 5, we're looking for the 5th term. N would be 12, that would be the power. So the formula is n choose r minus 1. N, the NCR button, r minus 1, one less than the term number we're looking for, times a raised to the n minus r plus 1 power, times b to the r minus 1 power. So for instance, find the 7th term of 4x minus y squared quantity to the 9th power. Let's solve that. Substitute. Let's first remind ourselves of the formula, and then substitute. 9 represents n, the power of the binomial. So that's 9. R is the term number we're looking for, so 7th term, that's going to be 7 minus 1. A represents the first term of the binomial 4x to the n minus r plus 1 power, so that's 9 minus 7 plus 1. Then b is the second term in the binomial with its sign, so that's negative y squared, and that's to the r, or 7 minus 1 power. Simplifying that, this is 9 choose 6, or 9 NCR 6. 9 minus 7 plus 1 is 3. 7 minus 1 is 6. When you do 9 NCR 6 on your calculator, you get 84. 4 cubed is 64. X cubed is x cubed. Negative raised to an even power is positive, and y squared to the 6th power is y to the 12th power. When you multiply 84 times 64 times 1, we get 5,376 times x to the 3rd times y to the 12th. All right, so again, that comes from combinations, which is n choose r, or NCR button on your calculator. That's the same as n factorial over n minus r factorial times r factorial. If you didn't have a calculator button, here's what you've got to do. For 9 choose 7, or 9 NCR 7, that would be 9 factorial over the product of 9 minus 7 factorial times 7 factorial. 9 minus 7 is 2, and you would do something like this. 9 factorial means 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Why did I stop at 7? Well, there's a 7 factorial in the denominator, and anything divided by itself will divide out to 1. So that saves me from writing and multiplying 7 times 6 times 5 times 4 times 3 times 2 times 1 in both the numerator and denominator. Those will divide out to 1. So I'm left with 9 times 8 in the numerator over 2 times 1 in the denominator, and that 2 will cross-reduce with 8 4 times. We'll reduce 4 times, and 4 times 9 is 36. Or 72 divided by 2 is 36. So if you didn't have that button on your calculator, you would have to do this process for each term. All right, well, that's the formula for binomial expansion when we're looking for the entire binomial expansion, or whether we're just looking for a particular term in the expansion.